Good morning, everyone. This is Elizabeth Graham, and I work at Wilson Tool. I want to welcome you to the latest webcast in our free webinar series, Practical Forming Solutions with Wilson Wheel Technology. In this series, we bring you expert solutions to common sheet metal manufacturing challenges in a convenient online format. Please note that today's event is being recorded, and you will be able to download the recording a day or so after the event. Also, note that due to privacy reasons, the attendee list is not displayed. If you experience technical difficulties during the WebEx session, you may contact WebEx technical support at the number on your screen, 1-866-229-3239. Also, as part of a large audience, you will be in a listen-only mode throughout the presentation. However, if you have questions for our presenter, there will be time for Q&A at the end of the presentation. So we encourage you to submit questions anytime throughout the presentation by using the Q&A panel to the right of your screen. Just type into the text box and send. But please make sure to choose all panelists in the Send To list, or your question may not be addressed. To submit a question when you're in full screen mode, just hover over the green floating toolbar at the top of the screen and select the question mark icon. In addition to myself, I'd like to introduce Vanessa Greer, who will be co-hosting with me today. We'll be sorting through your questions as they come in throughout the presentation. And now I'd like to introduce today's presenter, Glenn Schuldes, who is an applications engineer at Wilson Tool International. Glenn works with customers worldwide to support their implementation of new fabrication methods, including tooling, machines, and software. He can be reached at glenn.schuldes@wilsontool.com. With that said, I'll now turn the presentation over to Glenn.
Okay, so we wanted to talk today about wheel tools and practical solutions with the Wilson wheel tool. We thought that since the wheel tool has been on the market now for 20 years, now might be a good time to have an event like this and talk about it. There still seems to be a lot of interest in the wheel technology and the fact that it is quite different, so different from any other way of fabricating, especially on these punch presses. So let's go ahead and dive into what we have. We're going to talk about the descriptions of the basic available wheel tools, kind of material specifications, good materials, bad materials, and so forth, good and bad applications for wheel tools as well. So the basic types of the wheel tools, the way I look at them, there are basically four kind of families of wheel tools. The one on the left is the rolling shear, which is a wheel that cuts material. The upper wheel comes down and shears the material, and then as the wheel rolls along, it cuts the metal. Still a shearing operation, just kind of like punching or a guillotine shear would be. The second one is the rolling pincher. That's also a cutting type of wheel. In most cases, people are cutting with that tool. What that does is coin a groove in the top and bottom of the sheet that you can then bend back and forth and snap the material along that line. And then the other two wheels are forming tools. The rolling rib forms a bead in the sheet, and the rolling offset forms an offset in the sheet. Those two tools are very similar in type. So kind of the two on the left, I consider those to be cutting tools, and the two on the right, I consider those to be forming tools. And those are kind of the basic families of wheel tools. And everything, there's all kinds of different variations within these individual tools. But those are kind of the basics right there. So throughout the presentation today, we've got a couple of different polls that we'll ask some questions and ask you to respond to. And in the pre-registration, when you guys signed up to attend this webinar, we found that a number of you were already using wheel tools. And a number of you are still considering using wheel tools. So from my basic description that we just went through, kind of wondering if people are more interested in the cutting type of wheel tools or the forming type of wheel tools. So if you would answer that question and submit your answers, then after about 30 seconds to a minute here, we'll close that out and we'll talk about how you guys responded. In the meantime, I'm going to go on and start talking about the rolling shear tool is the first thing that I wanted to talk about. So the rolling shear tool, as we talked, cuts material. So I'll show a little video here of what the rolling shear looks like when it's cutting. So we'll pull that up here. So this is just a little short 10-second, 12-second clip cutting some 18-gauge mild steel. So that's the basics of what the rolling shear does. I'll show that again here. So the machine brings the tool down and rolls, and moves the sheet underneath the wheel and cuts. And again, that's 18 gauge or 1.2 millimeter mild steel. So that's the basic function of that rolling shear tool. Where do we stand on the poll? Has that been, we closed that out? So let's see, the results were 56% cutting, 44% forming, so kind of half and half basically is what we're seeing there. I guess that's probably about what I would expect. Thanks for responding to that. So back to our discussion about the rolling shear tool. We just watched that video of the rolling shear cutting along. The range of material that the rolling shear tool can be used on, typically we say the minimum thickness is 0.30 or 0.75 millimeters. And then the maximum thickness depends on the material type. In aluminum's 0.98 thickness, mild steel 0.74, and 0.59 stainless steel. That tool can be used to cut arcs, and if you watched on the video, was cutting some arcs. The minimum radius is typically about 1.75 inches for the minimum radius. That minimum radius, it's really important to understand that the minimum radius really depends a lot on the thickness of material. As you start cutting thicker materials, the wheel has much more contact with the thickness of the metal, and that kind of definitely increases the minimum radius. So say in 16 gauge material, instead of this 1.75 that we're talking about, you'd probably be looking at about 3-inch minimum radius, maybe in 16 gauge. The rolling shear is available for thick turret machines. We put it in a B station in that case for thick turret machines. In thin turret machines, it's adapted to the D size station, and then it's also available in Trump style machines or any machines that use a Trump style tool. Many of the things that we talk about with wheel tools are not real solid black and white answers, not yes or no answers. So when we talk, for example, about minimum thickness being 0.30, that's a real gray line when we talk about that. We do have customers that run much thinner material, but it depends on the exact application that they're using that tool in. For example, I think one of my next slides here, I've got some pictures about of good applications for wheel tools, and one of the slides definitely shows thinner material, thinner than that 0.30. And we'll talk at that time a little bit about how that might work. Reasons why you might use the rolling shear tool. Time savings is a big one. For some applications, cutting these big sweeping arcs like you saw in that video, the rolling shear can be much, much faster than punching or nibbling those arcs. Common line cutting is another thing we see a lot of. When you're cutting along that line, both sides of the part are usable. Reducing the need to buy nibble tools or to buy special tools to produce arcs. So again, if you go back to that video that had all those arcs on it, if you want tools to do all those arcs, that would be a lot of expensive tools to buy those, to punch those arcs. And improved edge quality. Because you're not nibbling the edge, you're doing a smooth shear, you don't have a scalloped edge or nibble marks along the edge. Large arcs is definitely one of the big things that we see people doing with wheel tools. It's very common that we see large arcs being cut. And relatively large parts in general are used. So cuts, if you're cutting a straight line, for example, generally what we see is 40 inches or longer for straight lines. Not very often that we see people cutting shorter lines in the 10-inch type length, 20-inch length. The wheel tool can do those, but modern punching machines can also punch those straight lines quite quickly. So I say here, avoid cuts less than 8 inches. Again, that's a gray area, but that's kind of what we see in the field. Customers are typically not punching or using the rolling shear, on shorter lines like 8 inches long. And if you're thinking about cutting strips, they should be 3 inches wide or wider. That's kind of typically what we see there. So here's a picture of a part a customer cut using a rolling shear. This is quite thin galvanized material, probably in the 24 thousandths range, about 0.7 millimeters probably. And we can see it's one large part with a large sweeping arc across the top, and then some lines that they would cut and pull away from the clamps while they're cutting those lines, and then an arc along the bottom. Here's another thin galvanized part. Again, we see these large sweeping arcs. That's typically what we see. Very common to see that kind of thing. And this is a much thicker aluminum part in this case. This is 080 or 2 millimeter aluminum. But again, it's the big arcs that are being cut. So if I back up, we see the big arcs are a very common theme. We also certainly see straight lines cut, but they're at an angle. For this particular machine, that machine probably has only 1.25 inch auto index, so we can eliminate a lot of hits that would have to be made to cut that straight line by using the rolling shear. And that's a fairly long straight line, probably at least 40 inches long. So that's the rolling shear. The next cutting tool that I wanted to talk about is the rolling pincher tool. And I have a little video of that. What the pincher tool does, I talked about, it coins a groove in the top and bottom of the sheet. So let's look at this video of the rolling pincher. You see the wheel is coining that groove in the top and bottom of the sheet. And then there's a little clip here at the end of breaking those parts apart. You bend the part back and forth, and it breaks on that line. I'll show that again quickly here. So it's the bending the parts back and forth on that line. That's kind of how the cutting happens. And so this is typically used on straight lines. Not always, but typically used on straight lines. Range of material is the same basically as what we saw for the rolling shear tool, 030 for a minimum, 098 aluminum, 074 mild steel, 059 stainless. Normally, this is used in straight lines. You can use it on arcs or contours. Typically, we say that minimum radius is about 20 inches because you still have to bend this part back and forth to break it on that line or arc that you're cutting. So if you try to do a smaller arc, you may not be able to break it on that smaller arc. This is also available for thick turret machines, B station, thin turret machines adapted to the B station, and trump style tools. So I think at this point, I got to go one more slide ahead, it looks like. So the rolling pincher, it scores the top and bottom of the sheet, both the top and bottom, so you can snap apart the parts on that line. It is common line cutting, so very often you're going to have apart on either side of the line. And it leaves a minimal burr. Just some pictures from that previous video that we were showing. Another application that we see used for the rolling pincher is to score the material. Instead of actually breaking the material or cutting it on that line, you see for this example that I show in these three pictures, the material was bent along those lines. It just bent by hand. So when you score the material, it weakens it on that line and you can bend it. In this case, I've run two lines close to each other to make a 90-degree bend. In some cases, we'll make special versions of this wheel. A customer will ask us to make special angles on the wheel, and possibly one of the wheels would be flat instead of having a point on both wheels. We can make these in many different configurations. And another possibility for the rolling pincher that we see on thicker materials is to eliminate these little overlap marks that you see that are very common to the nibbling process that's used on straight lines to cut thicker materials. If you take the pincher tool and run your line along the edge and then punch next to that, you don't see those nibble marks anymore. So we find that to be quite successful for some customers, especially on thicker aluminum materials. Not exclusively aluminum, but thicker materials in general. So now I get to my poll, which I thought was going to be a couple slides earlier. Again, some of you said when you registered that you currently are using rolling pincher tools or rolling shear tools. If you could let us know what is the most common material thickness that you cut with those. Either 030 or thinner, 036, 048, 059, or thicker, 074 or thicker. So if you could check that off quick and let us know. So about 10 more seconds, we'll close this out and see what people have to say about that. See if we get any kind of responses from you guys. We're working on pulling up those responses. Looks like the poll's closing. So 030 and 036 look like they're pretty common. 048 is a pretty small number, and then 059. So the number really drops off on the thicker material. So 059 and thinner certainly is the vast majority of what we're seeing. All right. So we can move on to talking about forming wheels. Kind of in general, those are the rib and the offset tool. The range of materials for those is a little bit different. So let's look at a quick video of the rolling rib. I'm going to talk a little bit more, though, first about the range of materials, from 030 on the thin end up to an 1/8 inch material on the thicker end. And it says on the screen 098 max thickness in smaller versions and up to 1/8 inch in larger versions. The forming wheels are made in a couple of different station sizes, and the wheels then have different axle sizes. So in the smaller versions, which fit in a thick turret machine, it would be in the B station. We typically maximum material thickness is 098. If we go up to the C size station in a thick turret machine, then we can increase that maximum material thickness to 1/8 inch. And the same is true in a Trump style tool. It's not a different station size, but we do make a couple of different versions of the wheel tool. with different axle sizes. The maximum height, 187 or 3/16 is the maximum height. In most cases, though, that maximum height may be limited more by other factors rather than what we can make the wheel to create. It's more a matter of what the material can withstand as far as the forming that's possible with the material. You can definitely run these tools in contours to do arcs. Minimum radius, roughly 1 inch. And this is available for thick turret in either the B or the C station. Thin turret, always adapted to the D station, and then in trunk style, a couple of different versions. So you can probably imagine what the forms might be used for. Increasing the rigidity, so a stiffening rib is pretty common. Creating decorative detail, creating functional forms. Maybe you have a cover that needs some clearance, an emboss or something along those lines. So the rolling rib, let's look at a quick video of the rolling rib. So it just rolls along the surface of the sheet to create a rib. Pretty simple. However, you don't have to just do straight line ribs anymore when you're using a rolling rib. You can do arcs. You can create lots of different size ribs. The rib wheel is made with the size rib that you want to put into the metal. And that size rib is made for a specific thickness. When we make these wheels, we have the material thickness that you're going to be using in mind. So the tool is specifically made for the thickness that you're going to be working with. Now we do stock a couple size ribs. I didn't list those here, and they might be listed on a later slide, but I don't think I did. We do stock 2 size ribs, but we also very frequently make custom sized ribs to suit your needs. Here's a case where the rib is run horizontally first and then turned vertically to make kind of a brick pattern. Here the rib is run around a circle, and then actually in this case the rolling shear comes by afterwards to cut out this disc. It's kind of a nice effect. So the rolling rib can be used in many different applications. Here's a case where the rolling rib is used to create a cross-breaking effect like you might normally do on a press brake. It can be very effective at that. And the rolling offset is a very similar type of tool. It's just a slightly different geometry on the wheels. It's only forming basically one side of the rib. So let's have a quick look at what that looks like when it's running. This is doing a little more interesting than just the straight lines that the rib tool was doing. It's going around some contours. So the rolling offset, there's what it looks like on a straight line. So that'd be a kind of the basic use for the rolling offset tool, just basically to replace an offset tool in your press brake. And it can be very effective at that. As you know, in the fabrication world, an offset in a straight line in a press brake is generally a dedicated setup or a unique setup on the machine. So it's quite time consuming on the press brake. If you can get that offset done while it's on the punch press, that can be a huge time savings. Here's also some straight line offsets. But again, because it's a rolling tool, using an auto index station, you can create multiple geometries, embossed patterns, any shape you need to create. So in a case like this, that would normally be a hard tool or some sort of very expensive tool to make that offset shape. Where a rolling tool can just roll along. It's great for making prototypes or shorter runs as well. Now, most of the pictures that I've shown up to this point of the rolling wheels have been what I would consider to be pretty good applications for the rolling tools. In many cases, we find that there are issues with the distortion of the material created by the wheel tool. So when you run a wheel tool, you're not stretching the material or thinning the material in the forms. So when you create the form, your material is being pulled from the surrounding area into that form. And that can oftentimes create sheet distortion. So that is, in many cases, what really determines what your maximum height is that the wheel tool can create. And I've got a couple of pictures here of parts that were distorted by running the wheel tool. So there's a simple cover, and they ran the wheel tool to run these stiffening ribs, and you see the distortion. And that's just a result of the material being pulled into this rib, creating that distortion. So if that rib was not quite so high, you'd get less distortion out of it. Here's a very extreme example of distortion. Using the rolling offset to create these emboss patterns created a lot of distortion in this part. And also in this case, using the rolling offset to create this complicated emboss pattern created quite a bit of distortion. Now in this particular case, this customer was able to use this. This is an acceptable result for them. The part is restrained in a way afterwards that this is okay for them. So it's very common discussion that we have with customers when they're talking about wanting to use a forming wheel and they want to know how high they can form. Question becomes, what's the part geometry that we're creating? We need to see the drawings, the material type, the material thickness, so that we can have an idea of how it might work in this specific application. So we just talked about four kind of basic wheel tool types: the rolling shear, the rolling picture, rolling rib, and the rolling offset. Those are kind of the four basic wheel types. There's also a lot of different things we do with wheels that I kind of throw in this custom wheel tool category. These are kind of basically variations of the four that we already talked about, but they don't really quite fall into those specific parameters. We talked about many of the wheel tools having a lot of gray answers as far as max material thickness and minimum material thickness and what's the maximum height that can be formed. These are probably even harder to define as far as the minimum radius, maximum height, max thickness, for example. So we really need to be looking at the specific applications in these cases. This is a tool we call a rolling flare. Now let's show a quick video of what that looks like when it runs. Very often used around the inside of a hole, maybe for a blower housing or something like that. And it forms up that edge. Comes up to close to 90 degrees. How high we can go with that depends on a lot of different factors. One of those factors is the feed clearance of your machine. But also the material type and thickness is very much a matter of determining how high we can go with this rolling flare concept. There's what it looks like if you look at a picture of it, and you'll see that it's not a straight up flange. We call it a flare, so it's a radius going up. So however high this flare is, that's kind of what this radius is. And it comes up close to 90 degrees. In this case, it wasn't run around the inside of a hole. It's run kind of along an arced edge. Makes a nice result for these parts. So that was the rolling flare. Rolling forge is another tool. Now, if you remember back a few slides ago, we had basically this same part when I was talking about the distortion. It had these 6 large emboss areas, and the part was very distorted. In this case, we have those 6 same embosses, but the part's almost perfectly flat. Now, this is a different wheel tool. It looks at first glance much like the rolling offset tool, but it is really thinning the material in between the wheels. So it's really squeezing the material along the form to make the material thinner in the formed area. That way it doesn't pull the material into the form, so the material will stay flat. And in this case, we've run 3 of those right next to each other, stacked them up so we get more height out of it. And you can continue with that concept and go higher. This previous slide, we're forming about 3 millimeters or an 1/8 inch high. On this slide, I'm forming over a 1/4 inch high, so a little over 6 millimeters high, maybe 7 millimeters high. And I get a pretty smooth edge, but it is a stair-step type of edge because I'm making discrete passes along that line. And then if we really want to get carried away, we can go a lot higher than that. In this case, this is formed nearly 2 inches high. And really, I could keep going with that height as long as I want to keep going around it. This was just an experiment that I ran to kind of see what it looked like. I made, in this case, I think it was 300 passes around this oblong shape, just gradually increasing the size to create this kind of cone shape. And I could keep going. I stopped here at about 2 inches high, but that could go, I wouldn't be afraid to make that go 4 inches high as well. The only limiting factor there is at some point you're going to start running into something on the upper end of the machine. Rolling knurl is a kind of a totally different type of tool, although it's, if you look at the wheel, it's going to create that. It's just a flat bottom wheel. And then the upper wheel has these nicks on it to create these nubs or knurls, whatever you want to call those. It's not truly a knurl from a machinist standpoint, but it's a kind of the closest description we could come up with. And that pattern can be, that's going to be defined by you if you were to order this tool. What do you want that pattern to be? In this case, it's just a decorative pattern to simulate a tire tread on this car that was created. I believe the original use for this, we developed it for a customer that needed some more grip for a sticker or some sort of adhesive that was being applied to the metal. They needed something for the adhesive to grab onto. And this tool is very similar to the previous tool, the rolling knurl, a rolling logo. We can create a wheel that's got a pattern on it, any pattern you want. In this case, we spelled out Wilson tool. So this is 1, 2, 3, 4 passes with that wheel. And it's just creating the logo once every revolution of the wheel. And I think that brings me to my next poll. This material shown in the rolling logo here is a stainless steel that's been treated with an anodizing, so it's a very hard surface in this particular case. So one of my questions here is, what type of material would you most commonly want to use your wheel tools on? If you were to have wheels, or if you do have wheels, would you think of using them on aluminum, mild steel, say cold rolled or hot rolled material, stainless steel, or some other kind of exotic material? Certainly in the fab industry, you guys are probably seeing, as we do, there's much more exotic or high strength steels being used these days. So that's an interesting question as far as I'm concerned. So let's see what you guys say about that. about 5 more seconds and we'll close this poll out. Most people are saying mild steel. Kind of an overwhelming majority are saying mild steel. That's good because it's a good application for the wheel tool. It's an easier material for the wheels to work with, more formable, easier to cut. So that leads me to kind of general wheel tool comments. One of the first things is, obviously, your machine needs to be able to run wheel tools effectively. And that includes most machines made in the last 10 years, probably. The machine needs to have a programmable ram of some type where the machine can bring the tool down and hold it in a position while it moves the sheet underneath the ram. It needs to have auto index. It needs to have the ability to hold that tool tangent to an arc if you want to be able to profile arcs. Material types and thicknesses. Material minimum thickness we say is 030, maximum is 098 for the shear and the pincher, 1/8 inch for the other forming wheels. Ideal thicknesses, what we see is kind of 060 in aluminum, 048 in mild steel, and 036 in stainless. Those are the majority of what we see customers doing. And I think that agrees pretty well with the poll that we did earlier here in this seminar. Your answer might have tended a little bit thicker than I expected it to. I think you were saying that 060 might have been your most common thickness from the poll answers. And the part geometry must be appropriate. Relatively large parts is what we see the most of, and long cuts is what we see the most of, or large radiuses is very common. So the wheel tools, it really is a situation where you want to look hard at what you're going to try to do with the wheels. Maybe send prints to us or talk to us about what you have in mind, what type of machine you have, what you want to do with cutting or forming, and we can look at what you've got and give recommendations as to how well it might work. Now, next thing I think is question and answer, and we've gotten some questions as we've been going along here, so let's see. First one is, can the rolling shear go in both directions? The instructions say it can only go in one. I'm not sure what the instructions we're looking at there, but definitely the rolling shear can go in both directions. Typically the one direction, my question there might be what is meant by directions. So the tool can cut left to right, and it can cut up and down, and it can be indexed to cut either at 0 or 180. So it really can be used at any angle, any direction. You would generally want to use a pulling action when you're cutting with the shear wheel, and that's true of all the wheels. You want to use a pulling action, so you have your clamps that are holding the material in the machine. You want to pull the sheet through the wheels as opposed to trying to push it into the wheels. Next question is the rolling pincher dedicated to a material thickness? No, it's not. It's typically made as a kind of a generic, the point sizes on the wheel are kind of a generic height, and then through programming your machine, you would set the depth to pinch the depth that you want. We can make the pincher specific heights if you've got specific point sizes in mind that you want us to make the wheel to, but in general, we would make a kind of a generic height to those wheels, and you can use it on multiple thicknesses then. That kind of brings me back to the rolling shear tool is made for a specific thickness, so you're going to decide what material thickness you want that tool for and use it then on that material, or maybe material that's slightly thinner than what it's made for, but not any thicker than what it's made for. Pincher is quite generic. Rolling rib and rolling offset, the forming wheels, while they're actually made for a specific thickness, they are typically used on a pretty wide range, even though they're actually made for a specific thickness. Next question we had was, is the max height for the rib or offset measured from the top or overall? It's from the top. So from the top of the sheet to the top of the form. So when we say 187, that would be from top to top. What are the stock rib sizes was the next question. So we have an 093 height and an 1/8 inch height. Those are the two that we stock. And they're made for 18 gauge material. Next question, how does the distortion of the rib wheel compare to a nibbling rib? And the question went on to say that they noticed that for a nibbling rib, the smaller the pitch, the less distortion they saw. Typically, we find that the rib wheel distorts the material pretty similar to what you see from a nibbling rib. In some cases, slightly less, in some places, slightly more, but it's very similar. Not a lot of difference there, because both tools really are pulling the material into the rib quite a bit. When you take the nibbling rib and you say that you're getting less distortion by reducing the nibbling pitch, what you're doing is really thinning the material out through the rib, so kind of a forging type operation like we talked a little bit about with some of the wheel tools. We can make the wheels do that forging operation in some cases. Something we could talk about if you had a specific application in mind. Next question is, when using the rolling shear, how do you remove the pinching when it hits the material? The easy answer is to say that you really don't, because that is when that wheel comes down. Let's see if I can stop this video where you kind of see, I think we're talking about this distortion right here at the end of the cut, and now the machine's going to rotate that tool and come down and restart. So you've got a little bit of a ding in the material here. Depending on your machine, you may not have much there for options. If you see the way this machine is running, I'll run through to the end and restart this video. If you watch that machine, it comes down to position, fully down to position before it starts moving the sheet. And that's the way many machines operate. They have to bring the tool down to a specific depth before they can start moving the sheet. And when that happens, you do get some distortion, or a pinch is what the question said at the beginning of the cut. Some machines will allow you to ramp the tool down so you can bring that wheel slightly over the top of the sheet and then ramp the wheel down slightly as it starts cutting. That can really ease that distortion that you see at the beginning there. It's a little more complicated from a programming standpoint, but it definitely can help. There are also things you could do either before or after making that cut that can eliminate that. You can come back with a forming tool to flatten that distortion out, possibly. In a case like I show on the screen right now with this video where I'm cutting basically a 90-degree corner, I might be able to cut past a little bit, and then after I start my cut slightly before, that might help with the pinch mark. But it definitely is an issue. We definitely, in some cases, it's just a fact of life that can't be eliminated. Next question was, what time savings on a 40-inch cut with the rolling shear? You probably would see about a 50% time savings. That's a really rough number. It's going to depend on the material thickness and the exact layout of your parts and so forth, but probably about 50% time savings. Next question was, for a straight cut, can you use a rolling shear in a non-index station? Absolutely. The only reason you need an index station is if you want to change the angle of the tool. So yes, definitely you can use a non-index station. So it looks like we're going to take about 5 more minutes here for questions. We're starting to get to the end of our time, so let's look at the next question. This is specifically about an Armada machine. Yeah. So he's saying in the program, evidently the programming system is outputting M692, M693, F1, and G0 at the end of the wheel run. what that's doing is on the Amada machine, the M692 causes the RAM to raise up. M693 cancels the M692 command. And then F1 puts the machine back in full speed mode, and G0 puts the machine back in point-to-point mode. So if you had been interpolating an arc with a G02, G03 command, or cutting a line at some angle with a G1 command, the G0 is going to turn that off. So that prepares the machine to go back into a mode where you would be punching holes in normal operation. Next question. Does the rolling pincher need to have material between the wheels at all times? All the wheels really should have material between the wheels at all times. And that's especially important for the rolling shear and the rolling pincher. If you don't have material there, when you bring the tools down, you can touch the two wheels against each other, and that's a good way to destroy your wheels. The question about the rolling logo tool. The rolling logo creates a stamped logo, not an embossed logo. So like a chisel point, like a letter stamp type of thing. Question about sharpening the wheels. How often do you sharpen and how? You don't sharpen them. The tools are made out of powdered metal that is very sensitive to machining and is really not sharpenable. So that's kind of the answer to that question. Question about if the tools, how the tools are working in the auto index station. Are they floating? No, they're not. They're keyed just like a regular punch would be. And the auto index, the machine is responsible for holding the tool tangent to the line or arc that you're cutting. So it's not like a wheel, like a caster type of wheel that's dragging along and creating its own orientation behind the path. The machine actually holds the tool, and the program holds the tool tangent to your entity. So I think that's about it for questions. So anything else coming in for questions that we wanted to answer?
Nope, that's it. So thank you so much, Glenn. Thank you, everyone, for joining us today. If you have any questions that weren't answered, or if you think of anything a little bit later, please feel free to contact your Wilson Tool sales engineer, or go to wilsontool.com. You can also reach Glenn directly at glenn.schuldes@wilsontool.com. Or if you have more general questions, you could email me or Vanessa at marketing@wilsontool.com. We'll be sending you an email in the next day or two with a PDF of today's presentation. That also includes a link to the recording of this webinar, so you can go back to it and watch it again. You'll also be able to find a recording of this webinar, as well as any of our previous webinars or webinars that we're going to have on our website under the Media Center tab. We hope you found this helpful, and we look forward to working with all of you in the future. Have a great day, everybody.